Hello friends, welcome back. So now we are going to talk about one more theorem, and that is Thevenin's theorem. Thevenin's theorem says if we have a linear two-port network connected with one external load, then the whole network can be replaced with a series combination of one voltage source and one resistance. And this voltage source is called Thevenin voltage and Thevenin resistance, so VTH and RTH. So this is the theorem. So now we need to find that if I have a circuit with me, so something like this is my load resistance, then what is the Thevenin equivalent for this whole circuit between point A and B? So we need to identify two quantities. One is VThevenin, one is RThevenin. To find the VThevenin, just open the circuit between A and B. VThevenin, for the same reason, is also called V open circuit. Just open A and B and apply KCL, KVL, anything, and find the voltage between A and B. That will be our VThevenin. To find RThevenin, disable all the independent sources between A and B. So that means this 2 ampere will be replaced with open circuit, this 32 volt will be replaced with a short circuit. And now we will be left with a resistive network. Find the equivalent resistance, and that is our RThevenin. So for example, in this we can see, if I have to find RThevenin, then 4 and 12, they will be in parallel to each other, which will make it 3 ohm, and then this 3 ohm will be in series with 1, and that is why our RThevenin will be 4 ohm. When we open circuit, the same circuit, to find VTH, then this is my equivalent circuit, and you can see that no current is going to flow in this 1 ohm resistance, so we can remove it also from the analysis. And now you can use KVL, you can use KCL, you are free to use anything, and that will be our VTH. So once we are able to identify VTH and RTH, then we can say then the whole network is replaced with a series combination of VTH and RTH. Now there can be some complications, that if we have one dependent source. So if I have to find VTH, nothing special, open circuit between A and B and find what is the voltage between A and B. So that is all. No complications here. But when I am finding RTH, I can disable 5 ampere, but I cannot disable this dependent source, because as soon as I say 2 times Vx equal to 0, disabling a source means they are equal to 0. That means I am also saying Vx equal to 0, which is not true. So I cannot disable it. That means I don't have a purely resistive network. So I cannot find RTH using the method. So in that case, we need to have something special. So what we will do, I will supply one external voltage source. We can call it V test, or we can say it is having a constant value of 1 volt. And then I will measure how much current is flowing here. And V test by this current, that means the ratio of these two will be the equivalent resistance of this network. So that is exactly what we are going to do. For RTH, we will put a test source of 1 volt. For VTH, no changes, just find the VOC. So by doing this, the ratio of voltages and the current, so this was 1 volt source, this is the current which got generated, and their ratio gave us the value of RTH. So friends, this is about Thevenin theorem. And now, just parallel to Thevenin, we have Norton's theorem. Norton theorem is nothing. It says the same linear two-port network can be replaced with a parallel combination of Norton current and Norton resistance. Basically, if you see source transformation theorem, when applied to Thevenin theorem, give rise to Norton theorem. How to find Norton resistance and Norton current? Norton resistance calculation is nothing but Rn is nothing but RTH only. Same method. Whatever we did for finding RTH, that means open circuit, disable independent sources, find equivalent resistance, we are done. Or if there are dependent sources, then apply V test, we are done. And how to find IN? IN is also called I short circuit. So whenever you are given a network like this and you are asked that what is the current flowing between A and B, so we will say, okay, attach them, make it short circuit and find what is the current flowing here. When I am making this as a short circuit, I realize that I can remove this 5 ohm and just apply either KCL or KVL and find this short circuit current. So I short circuit will be our I Norton and RTH is our R Norton. So this is how we deal with Norton theorem and Thevenin theorem examples. Keep learning. Thank you.